Welcome to one of Mid-American's coal-fueled power plants. The power plant you'll visit during this tour generates approximately 748 megawatts of power. That's enough to bring electric power to about 500,000 homes or businesses. This large device that looks like a Ferris wheel is the stacker reclaimer. It helps direct coal into the power plant or to the storage area. The unloading facility actually picks up the train car to pour the coal out. 120 cars of coal can be unloaded in a 5-hour period. This is the coal conveyor tunnel that sends the coal into the power plant to be processed. It is nearly a quarter of a mile long. It can move 900 tons of coal per hour. Coal enters the power plant and drops into coal silos, the white tanks you see here. From there, it moves through a coal feeder into the pulverizer. There are a total of 7 pulverizers in this power plant. One of the black tubes you see moves coal into the pulverizer. The pulverizer is the big red tank at the bottom of the tubes. This churns the coal into a fine powder. The other 8 tubes send the coal, now a fine powder, to the furnace. About 70 tons of coal can be pulverized per hour. As the coal reaches the furnace, it combusts into flames, the first step in creating thermal energy. The coal entering the large furnace causes combustion, or a small explosion of fire. This creates hot gases that rise to heat water and create steam. Steam is created in the boiler drum near the top of the furnace. This generates the thermal energy, which is transformed to mechanical energy at the turbine. The main pipe above and outside the furnace is the main steam line to the turbine. This walkway shows you the series of steam lines headed to the turbine. This turbine is the primary piece of equipment that transforms thermal or natural energy into mechanical energy that can be harnessed to provide power to homes and businesses. Inside this piece of equipment is a series of turbines that lead to a large generator. The turbines are connected by one long shaft. The first one you see is where high-pressure steam is introduced to begin to rotate the turbine. Steam goes back to the furnace and arrives at the second turbine. It is 1,000 degrees with 550 pounds of pressure per square inch. The series of turbines spin at 3,600 revolutions per minute. This creates the power needed to spin the turbines and power the generator. The generator is the last section and creates the electrical charge. It creates 20,000 amps at 24,000 volts of electricity continuously. The silver tube below the turbine contains large copper bars, which carry the power to the generator step-up transformer outside the plant. At the step-up transformer, the voltage is increased from 24,000 to 345,000 volts. Electricity flows through the switchyard that determines the transmission line or path. Electricity is like plumbing. Where you turn the water on is where the water flows. Electricity is pulled to the source where it is needed. At the substation, voltage is lowered so it can be moved across utility poles. Some poles have a transformer that steps down the power for use in homes and businesses. These lines are flowing with an incredible amount of power, and contact should always be avoided. Energy touches everything in our. This is the precipitator box. It extracts fly ash from gas left over from the combustion process. The poles, or wrappers on this box, shake fly ash from a vibrating wire. The gas left over from the combustion inside the furnace flows into the precipitator box. Entrained in the gas is fly ash to be captured. As the wrappers sitting on top of the box are slammed down, the fly ash drops into a tube. A transport blower sends the fly ash into the silo to be loaded into a truck. About 500 tons of fly ash is captured each day. Fly ash, which used to be a waste product, is now recycled to make a higher-grade, non-porous concrete used on highways. After the power-making process is complete, what is left is spent energy, or unusable steam. It needs to be converted back into water by use of a condenser. The water circulates inside this big silver drum to begin the cool-down process. It then heads to a cooling tower outside the facility. 12 fans at the top of the tower pull air through the water to continue to cool it. Additional water is suctioned to circulating water pumps to further help cool the water. In this power plant, the same water is used over and over again in a continuous cycle.